Welcome back to our lecture series on advanced textile printing technology. Continue from where we had left last time. So, what did we do last time? We learnt about the cost of inkjet printing, and we understood that for short runs is definitely less than the regular printing techniques. The cost of course depends on the print head robustness, one ink versus the other ink, aqueous ink versus the non-aqueous inks, or continuous jet inkjet systems versus the DOD systems. All that of course will have some role to play. Substance, that is the substrate and the suitable ink types, and in general pre-treatments that we need to do are the ones which are going to be responsible for the cost. We move further. We talk about inks little more. Inks, as we know, basically are the main stay of this inkjet printing, and so general properties of the inks are going to be more important for everyone to learn. So, we do not have any doubt on this that printing is possible only if the ink is more likely to adhere to a different material than to itself. So, in general ink would have a pigment or a dye, which of course is what is needed, and of course there is going to be a medium which controls the ink's cohesiveness and adhesiveness. It may have several components within this solution of which is called the ink. It could be binders, it could be solvents and many other things which would change the behavior, the flow behavior of the ink. In general, the viscosity and surface tension are going to play an important role. You can appreciate that the inks which we use for inkjet printing are low viscosity systems. If it was a very high viscosity system, then obviously it will not pass through, unlike for example, our conventional printing. So, conventional printing uses print pastes which have very high viscosity. So, we are much away from that. It is a very low viscosity system, and surface tension is generally we expect it to be higher. What do we mean by that? If the surface tension is higher, this drop as it comes out will become spherical, and then the dot which is going to be created will be more circular. So, if the surface tension is very low, then it may have a tendency to spread. So, we would generally prefer low viscosity, high surface tension. So, let us look at it a little more carefully as to what exactly would we mean by that. Let us look at how the drop is formed. So, there is actuator which may be piezo based actuator or any other actuator, thermal actuation which puts a bit of a force onto the system, so that the drop is thrown out. So, what happens is individual ink drops are ejected from the nozzle, and you apply a pressure, and the pressure is by various actuators at frequencies which are predetermined. Like we already probably know that the DOD type of machines or systems require less frequency compared to the CIJ types, and so based on that frequency there are going to be pulses which are going to be ejecting the drops. And as the drop exits the nozzle, the shape is near spherical with a long thin trailing ligament. For example, if this is the exit of the nozzle. The drop initially may come like this. As it moves further, so it may actually have a spherical thing with something which is extending, we calling as a ligament. So, at some stage it has to break. What happens when it breaks? This trailing ligament which is attached, it has to break. So, when it breaks, part of it will go to this and part, depending upon where it broke, may go back. This is how the drop may like to form. So, we expect that the ligament breaks subsequently due to instability, because there is gravitational force and the push which is taking it away, and then it may, while it is breaking, may also create something which we call as a satellite drop, small droplets also. While you may have a big drop which is going to become spherical, and small drops as it is breaking may also get created, all right, and this will be then called like satellite drops. I do not think it is a good idea. The satellite drops can create unwanted splash on the target substrate, whether it is a paper or a fabric, and this obviously means there is a reduction in print quality. So, how do we control the satellite drop formation? We want to control this. So, one of the ways is that you can add some viscosity builders. And what is a viscosity builder? There may be some kind of a polymer which obviously increases the viscosity of the ink. Now, this helps to a great extent, because then what happens is that this so called ligament, when it breaks, would have a tendency to shrink towards this and not break into satellite drops. So, a bit of a change in viscosity can change this behavior, and you may not have satellite drops being created. So, why does it happen? So, because of this small little increase in the viscosity, there are elastic stresses which help this trailing ligament to be pulled back, pulled to the drop itself and before breaking up from the nozzle. So, this is one way the ink manufacturer would like to control, and which definitely will help in the quality of the print produced. So, what becomes important? The rheology. Normally people will say, well, you are working with a very low viscosity system, so how the rheology becomes important, but that does become important. So, let us talk little bit about the rheology of an ink. So, what is rheology? It is a study of the flow and deformation of a matter. In our case, it is the ink which is flowing through a nozzle. The two properties are important. One, obviously cohesion, which obviously relates to the ability of the ink to hold together, and the other is adhesion, which relates to its power to stick to a different material. In our case, it could be the textile fabric. So, cohesion, so that the ink or a drop remains as a drop or becomes a drop. Adhesion is the property with which it adheres to the other material, which is the textile fiber. These are two things we will be expecting. As we mentioned earlier, we are dealing with low viscosity system, which is approximately equal to 20 CPS. The stress should be low again. Why? Because we are working with very minute actuators, which may not be able to sustain very high stress levels. So, what does it mean? It means that we will still want the viscosity or the rheology to change in a manner that the ink flows much more easily when required, so that the stresses on actuators are less. Yield stress and the meniscus affect the latency. That means, whatever polymer system that we are going to be adding, they will modify the rheology. Viscosity at low shear rates, in addition to the surface tension, they determine the fill up. Fill up means whenever some volume goes out of the chamber, something must come back. Cleaning and priming of nozzles, because this is important. There is a station at the end where the print head goes and rests at the end of the machine. Here this is called priming, and here there can be some cleaning also happening, so that the next time when it goes for the printing to the other direction, the jetting is very nice. So, it is always in a ready to jet condition. So, we just talked about some polymers being added. So, these are also called rheology modifiers. We just understood why it would be needed. Maybe this would help us to reduce the satellite drop formation. Viscosity of the ink will change a bit, of course, but still not so much, but little bit, small little changes will take place. So, some of the materials which can be used as rheology modifiers are like polyethylene glycol. The molecular weight could be ranging from several hundreds up to hundreds of thousands can be used as the rheology modifiers. So, remember, although viscosity is low, the rheology is very important and we cannot be ignored. We cannot ignore the rheology of this ink, which actually has a low viscosity. And so, the measurements which are done of viscosity, the method that we used earlier, may not be very suitable for this type of a material, because the ink is experiencing various types of pulses, pushes by actuators at frequencies which are very high frequencies, and therefore, the behavior should also be tested by instruments which work at high frequency. For example, high frequency rheometer, a condition which can be mimicked by these rheometers, which are approximately the same type of condition which the ink experiences in the channel. At high frequencies, the ink jet fluid exhibits a low level of non-Newtonian behavior, which also strongly influences the jettability, fluid jettability. So, now we have the term jetting, which sometimes people used, ready to jet. So, basically this refers to breakup of the drop is called the jetting, which gets influenced by, obviously, as we said, rheology as discussed just before. So, small amounts of polymer demonstrates different breakup dynamics. So, which means in flight fragmentation when it is just been detached, and how fast, how readily, how easily the drop gets detached from the nozzle. So, that is what is jetting. If we add polymers which are in higher concentration, obviously it may not be a good idea, because it will adversely affect the jettability. In fact, if you have too much of polymer, it can clog the nozzle itself. So, then the other property is surface tension. you can understand very easily that surface tension affects drop formation. You can appreciate why is drop formed. It is formed because of the surface energy, which becomes the least when it is spherical. And if it also would help or look at the behavior in the satellite formation, if it is very high, then every small droplet that get created also becomes a satellite. If it is a very low surface tension, which is also not very good, because then everything will in a way start flowing. So, an optimum level of surface tension is required, because finally, we want a drop to be spherical and we want the dot to be a circle, a dot which is going to be created on a textile substrate. And you can appreciate that surface tension properties would determine whether the drop will very easily spread or it will just stay there where it is before it is dried. So, all the interactions with the substrate also will be governed by the surface tension properties. Now, in this case, obviously a surfactant, whatever, for whatever reason you add a surfactant, will play an important role, because surface tension will change whenever you add any surfactant. Generally, it is as a thumb rule, a high HLB value of a surfactant would help stability of a colloidal solution. Colloidal can be there because you may be using particles which are pigment particles and something like that. Low HLB value will give you low surface tension. It can also help you to keep the nozzle capillary always wet. It can also help to maintain a meniscus at the nozzle tip, and it can also be reliable jetting. And as we said before, that interaction between ink and substrate can also be affected, dot and image quality, both of them are so important to us. So, what do we do? So, you have to do a good balance, what kind of a HLB of a surfactant we would want. So, it is not going to be an easy thing. So, too much high will do the colloidal stability, which may be very helpful for us, but if it is very high, then surface tension and other things are going to be affected, jetting will be affected, and so one may have to do a balance between the colloidal stability and relatively low surface tension. Here also we have already mentioned that it cannot be the situation where surface tension is so low that the ink has more tendency to float and the ligaments will be longer and so on and so forth. So, as we believe that here also some short chain ethylene glycol based non-ionic surfactants may be optimized for their properties in the with the term with respect to the colloidal stability and the wetting and other jetting reliability of the ink. Viscosity we just talked about before also. In effect, we are talking about the shear viscosity. So, it controls the flow through the print head nozzle. Due to small nozzle diameters, you can understand so many of the nozzles are there in a very small area. The fluid actually, while it is coming out, operates at a higher shear rates. It affects the filling of the ink into the print head also. So, when it is coming out, it should have with a high shear rate, but when it is stationary, then its behavior is different. So, the behavior of the ink, whether it is going to be shear, thinning, shear, thickening, this is what will be important for us to learn. So, we again revise that the viscosity is low generally around 20 CPS. We also understand if viscosity is too high, clogging and other things can happen. And we also understood that even at this low viscosity, the rheology profile cannot be ignored, and it is controlled with relatively high molecular weight water soluble polymers. When so many things have to be added, people will have to worry about the synergy between all the ingredients that you may be adding. So, one thing is clear, it is not just a simple ink which has only pigment or dye. There are many other ingredients which are going to be looking at the rheology, the viscosity, the surface tension of the ink. So, do we require shear thinning? Yes, we do require shear thinning, because the time taken for this, even the smallest droplet to come out of the nozzle is very, very small, and therefore, rate is very high. And so, if it is not there, there will be back pressure develop, the actuators may not work very nicely, they may get affected adversely, the functions may be really affected badly. And so, we do require shear thinning behavior of the inks for printing. Startup, that is, when the machine is started, how much time does it take? 0 time to start printing, or you think there may be some more time required before good prints start appearing. This is an important thing. So, that is what people do, that the print head goes to the ends of the carriageway, where it is called priming, it stays there. If anything is sticking, it may be cleaned also at that station before printing startup. But therefore, startup is an important thing. One would like obviously the machine to start printing immediately, it does not happen. So, there may be something. So, there is a time that requires, and that is sometimes known as the latency. Latency is basically the number of firings needed to establish the first stable drop for jetting. If something is sticking somewhere, some portion is dried up, the holes are not really clean. So, it takes how many firings it is required before everything smooth comes out, is called latency, and this is what sometimes known as startup issues. So, among various ink types that we use today, we will look at pigment inks. Pigment obviously is a colorant which, as we understand, does not have any affinity. We should not say any affinity, there will be some affinity for everything. Everything have can make a van der Waals force and so on and so forth, but when we talk about affinity, we mean either it makes covalent bonds or it makes ionic bonds or makes hydrogen bonds. Specifically, those things are not there, and so advantage obviously is there. Advantage is that it can, if it can be fixed, it can be fixed to any substrate. So, this is the prime advantage we can think of. All substrates can be printed, even the blends of various fibers can be printed, and therefore, process becomes simpler, and which means print, dry, and probably maybe cure also. So, that drying may be at a temperature which is higher enough to ensure that there is a film which is been cured and fixed onto the substrate. I am sure you understand that, because as we said, pigment does not have any affinity, therefore, something is going to bind it, and that is because the binder which makes a film. But good thing is that you do not need to wash, because everything is fixed. Of course, we have lot of expectations whenever we look at ink also, pigment ink. One of the expectation is that it should last quite a lot. Think of the print paste that we were making. We expected it to last for a day, maybe 2-3 days. The stock thickening may be a little more than 4-5 days, maybe a week. That is the maximum we can think of. But the shelf life of the inks is expected to be up to 2 years. That means everything, all the ingredients which we just discussed before must remain functional and keep doing their functions. We expect low viscosity and reliable jetting, definitely. Now, we are talking about, remember, pigment inks. Pigment inks, of course, we will wish good wash and rub fastness. A rub has come here because now you are looking at a textile substrate, you have some pigments and then there is a film which is holding. So, expect either in wet rubbing or dry rubbing, if the film breaks, then things can be different. Now, the binder, where is it? Is it inside the ink or outside the ink? Normally, people will prefer the binder to be inside in the ink itself. And so, if this is a film forming substance, then it may result in some clogging here and there, but we expect it should not. So, with those expectations and the something which we learned before touching the pigment ink. So, the formulation of a pigment ink is going to be quite a juxtaposition of various kinds of chemicals based on the requirements. Of course, there will be pigment, and pigment is not generally water soluble, and therefore, this will be a dispersion. So, this will be a dispersion. So, that of course, will be part of any pigment ink. But the most important is pigment will have a binder, because this is the one which is keeping the pigment inside. Water, we generally prefer aqueous ink. So, therefore, there is a dispersion of the thing and there is a polymeric binder, and so some water, aqueous systems. A co-solvent, so that the surface tension and wetting properties are modified to suit the requirement. It will have the purpose of wetting, adhesion to the substrate, and good jetting. Some of the examples which compounds which can be used are pyrrolidons or propane diols, etc. Surfactant, which obviously modifies the surface tension, and humectants, because sometimes when we are drying, all the reactions, it should not become such that everything is too dry. So, a bit of a moisture may be advisable. So, after drying particularly. Anti-foaming agent, because whenever it is in the chamber, it is going to be at a very high frequency, this is going to be impacted, and so we would not want any foam. So, anti-foaming agent may be a part of it. Viscosity controlling agent, as we said, a little bit of a polymer could be added, so that viscosity is controlled. And a biocide, because if you are looking at something which has to stay for years together, so we expect that no change should take place, biodegradation or biological growth should not be there, otherwise a lot of other things happen which obviously are not good for anyone. So, let us say pigment dispersion. So, what pigment will depend on the color gamut? I mean, normally we expect 4 colors should work, but in case required more could be used. White is one other than the CYMK, we may have white. Of course, we expect these to be having high light fastness. Pigments would be dispersed obviously, because they are not soluble in water, and dispersion stability is what is going to determine the shelf life. If the particle size is very, very small, they could be self dispersing. Otherwise, you may have to use a polymer based dispersant which can assist the good dispersion happening. Now, what is the particle size we are looking at? Approximately 0.5 decimal, 0.05 to 0.15 micron size. So, it is a small size, so that should be able to come out of the nozzle without any hindrance. Distribution of particle size. So, particle size distribution we are talking about. So, you can have a very sharp narrow distribution, or you can have a broad distribution. So, obviously, one would like to have as narrow a distribution as possible, but it is always a challenge. It is not easy to do, but the milling is the operation which is done, so that the particle size is brought down to a certain range. If it is too broad, obviously it is not good, because there will be large number of particles, or there will be relatively large number of particles which will have very large size. So, big particles will have a problem, that because of size they may have effect on settling down by the gravity. They would obviously very naturally may be the ones who are responsible for clogging. The finer ones keep moving out, the larger ones may actually get stuck, and that would lead to startup and jetting problem. If the size is very low, below 0.5 microns, so what happens? Very, very small size, very, very large surface area, overall surface area is very large. Keeping them dispersed is a challenge. Very small particles will have a tendency to agglomerate. And so there is the approximate range is 0.05 to 0.15 micron. Image quality, does it get affected by the size of particles? So, it is approximately understood that higher color density or a holdout, sometimes called, the big particles are responsible for that. The smaller particles actually lead to an effective use of color, and generally if for a glossy substrate they are used as a smaller particle. But the best reason why a particle size should be have a certain value would basically depend on more on jetability rather than only looking at the color density and so on and so forth. Now, the dispersion, how much should be the solid content of the pigment dispersion? I mean, one can have dispersions percentage varying from 10 to 40%. Higher is the solid content, better for transport, and this dispersion finally is going to be mixed with solvents, co-solvents, surfactants, viscosity modifiers. It gives you more flexibility, because the concentration is going to be only diluted. Well, typically you may get surfactants with the dispersions and solid content of about 20% or so. Other essential things which must be part of the ink is the binder. It is essential. Without the binder, there is no pigment ink printing. So, incorporate a binder in the film. These are film forming things, film forming substances, and therefore, for a long time people thought let the binder not be there in the ink because it can have gelling and other effects, but then that would mean that your pre-treatment or a post-treatment will be different. When do you add a binder? So, the binder had to be in the ink. If binder is not in the ink, what do? We apply the binder to the whole fabric and then do printing, or we do the printing and then apply a binder on the top. That means binder will be all over the fabric where the design is not there. If the binder is in the ink, then the binder will bind the pigment only in the areas where there is design. When there is no design, there is no binder. So, it is logical that you want the binder to be in the ink itself, but it obviously has some challenges. The polymer should have low glass transition temperature. Whenever you make any film or put any film, laminate anything on top of a surface of the fabric, rigidity increases, flexibility changes, and you do not want that. So, how do you help that? So, low glass transition temperature, that is what helps the cause. For textile, it is required more because the textiles, the printed textiles will have to be washed many times over. If it was just a pigment printing on a surface which is not to be washed like a paper or a wall, then life will be very different, or a panel. But textiles have to be washed, and therefore, generally higher amounts are also required. Storage stability of the ink. So, one may have coagulation as we said, and there can be phase separation between things which are very soluble in water versus very less soluble in water. All that can cause a problem, and binders therefore prove to be more difficult ingredient. If things are not right, jetting may not be reliable. As I said, if the binder, which is a film forming substance, can make some gels anywhere, then it can get stuck around inside or in the nozzle or completely block it. So, clogging can take place. So, we expect the binders to be generally soluble in the ink medium, so that phase separation does not take place, but water insoluble. So, that means you have other solvents which will help the binder to remain in solution, but they will be generally in a way dispersed. They are either random or block copolymers of which have a soft segment. So, that you remember we require low glass transition temperature, cross linkable or non cross linkable. In case they are the cross link, they should be finally have the film, but whether the cross linking should be done inside, should be part of the ink or should be outside, will have to be based on situations, but normally we would like the cross linkable polymer which can form a good film, which will adhere and have good wash fastness. Sometimes to avoid these gelling issues, because they are not water soluble or they are less water soluble, but they definitely are hydrophilic compounds to begin with. They may be encapsulated and they get really exposed when they are outside. So, they would not gel inside, they would not clog the material, and once they are cross linked, they will become less water soluble, because if the cross linking takes place before it is ejected, then it is a hopeless situation. Some examples we can think of: the solvents, co-solvent, humectants. Water obviously is a carrier which may form about 80% of the volume. So, the co-solvent, water soluble organic compounds may also double up as humectants as well. That would means you will have to add less amount of material. For example, we just said propane diols or pyrrolidones, and polyethylene glycol, polypropylene glycol, glycerol, etc., may form another group of chemicals to be added. When we add so many chemicals, obviously we will be looking at the compatibility. It should not happen that because of one or the other there is coagulation, settling and breakup of the dispersion. So, today what have we learnt? We have learnt that ink rheology has a role to play. The viscosity of the ink is low, but as the systems operate at a very high frequency, it has significant effects. The shear rates can be very high around the nozzle. The measurement therefore should also be done, measurement of this rheological measurement should also be done with instruments which operate at a high frequency. Normal thing that we said, we are operating at a very low frequency, or which is not simulating the what is happening in the jet. Role of surface tension and the viscosity is what we understood, and also we learnt as far as the pigment inks are concerned what are the essential components. So, we stop here, and next time we will pick up other topic on this printing inks, and maybe we will take up other types of inks used for inkjet printing. Thank you.